Before you even start studying for the Econ Stats final exam, it's really important to get a handle on vocabulary and notation. That's what this video is for. I'm going to show you all sorts of vocabulary and notation that you need to know and absorb even before you attempt your first practice test. First off, when we attack a certain problem, we want to make sure we separate those things that belong to this population and those things that belong to the sample. So a population mean uses the Greek letter mu, while sample uses x bar. Standard deviation or population standard deviation uses sigma, and because of that the variance would be sigma squared, while standard deviation for the sample uses s, and the sample variance is s squared. Proportion uses p for the population, while sample proportion uses p hat or p bar. These are usually used interchangeably. I use p hat, but Dr. B uses p bar. Okay, we've got that down. Now I want to talk about, briefly, sometimes you'll see a sentence that begins in the sample, and then you'll hear they'll say the mean is 50 or the standard deviation is 30. But because they've prefaced that sentence within the sample, you know they're talking about x bar or s, because I said mean and standard deviation from the sample. Okay, let's jump over to sample size, degrees of freedom, all this stuff. Each of these are also variables. Now, these aren't separated by population or sample. These are true regardless whether you're talking about the sample or the population. So sample size, that's n. Degrees of freedom, that's usually denoted by df, and that can usually be n-1 or nx plus ny minus 2. We'll get more into degrees of freedom a bit later. Significance level, that's alpha. Confidence interval uses something called a confidence level, which I usually denote by CL. The rejection region tends to use that value of alpha, so that's going to be here. And as well as we use what's called a critical value, or sometimes we use two critical values, so we might say CV1 and CV2. So that gives you all the notation associated with these 5 things here. And then the last thing I want to talk about is null hypothesis versus alternate hypothesis. Sometimes we're making a claim about a parameter mean or a population mean or standard deviation or proportion, and we'll write something like the population mean, mu, is bigger than 10, bigger than or equal to 10. The alternate hypothesis will be the flip of that. That is to say, if mu is greater than or equal to 10 for the null hypothesis, that means the alternate hypothesis will be mu is less than 10. Now, of course, there's all sorts of different ways we can create our hypotheses. We could say something like mu is greater than or equal to 10. This would be our null hypothesis. We denote that with h sub 0. While our alternate hypothesis would be mu is less than 10. This would be a left-tailed test. So this would be left-tailed. We'll go ahead and label that. This is left-tailed because we're looking at HA. The alternate hypothesis tells us what tail we're using. So less than 10 would be a left tail. If we go ahead and say H null mu is less than or equal to 10, while the alternate hypothesis is mu is greater than 10, this would be a right-tailed test. And then lastly, we have the two-tailed test. That corresponds to the null hypothesis being mu equals 10, while the alternate hypothesis would be mu not equal to 10. And this will be two-tailed. This is all the vocabulary I wanted to go over right now, but make sure you absorb this and know that when you tackle any problem that you're going to encounter on the final exam, you're going to see many of these things crop up, and it's important to make sure that you label them correctly and accordingly to this chart here.